In this demo, you will see a proof of concept command line wallet that demonstrates how easy it is for enterprise customers building on Lockkeeper to secure and manage keys on behalf of their users. Our demo highlights 4 capabilities of Lockkeeper embedded wallet as a service. The first is the private key. Private keys are generated in a secure enclave environment in the cloud. We're currently building on AWS Nitro, and this provides confidentiality of the key material protected by Lockkeeper. Number 2, customers can pick from multiple key types based on their desired performance. On one hand, we have Shamir secret sharing, which splits a private key into shards, encrypts them, and the Lockkeeper core distributes those encrypted shards to multiple key servers. Now, whenever a transaction request for signature comes into Lockkeeper core, the shards are retrieved from the key servers and decrypted inside of the enclave, and then put back together into a whole key to sign the transaction. At that point is when we check for policy, and then when the transaction is signed, the key is immediately deleted inside of the enclave. The next key type is MPC, or threshold signature schemes. The private key in this is generated in a distributed fashion across the key servers. The key is never reconstructed at any point in the lifecycle of the key. Now, whenever a transaction request for signature comes into Lockkeeper core, partial signatures are generated at the key server with each shard. Then the partial signatures are combined to form a complete signature for the transaction at the Lockkeeper core. Number 3, the policy engine. Our policy engine allows for programmatic enforcement of rules in a way that limits the use of keys. And this is based on certain conditions, which we call policy scope. And a policy in Lockkeeper defines who the approvers are for a particular key and transaction. The approvers provide a digital signature to authorize or reject a transaction from being signed. The fourth feature is host your own key server. This feature allows customers to host a key shard in their own cloud infrastructure. This capability allows our customers to control one of the key shards, distribute the security of their key across multiple cloud providers, in addition to easily meeting compliance requirements. The demo shows how customers can set up an auto approver that approves transactions where the addresses are in an allow list below 1 ETH, and anything above will be rejected or require a manual approval. In summary, Lockkeeper Wallet as a Service can support any EVM-compatible chain either at L1 or L2, and we are very excited to extend our APIs to other blockchains given the Web3 infrastructure that is now abstracted away by the Lockkeeper API. Now for the demo. As I mentioned, you will see an auto approver that authorizes transactions based on an allow list or a transaction value being below a certain threshold. By design, approvers can be complex or as simple as needed for a Web3 use case. And with our approach, we have been able to demonstrate integrations with customers across multiple use cases in Web3. With AI agents, Lockkeeper can provide the framework for agents to execute Web3 tasks safely on behalf of a user, but we require approvals on transactions, either auto-approve or slow it down by requiring a manual approval. And then with digital inheritance, Lockkeeper provides a secure escrow capability such that users can safely pass on their assets to beneficiaries with approvals after their passing. With restaking, Lockkeeper allows stakers to secure their native assets while participating in staking ecosystems without compromising security or usability. All of these use cases require the same fundamental security components, and Lockkeeper provides that functionality with a very simple API. And so now I'm going to show the approver running, which is local. Now this approver can also run in the cloud, can run in different environments. It is really up to the customer to decide, but they can customize it however they see fit. And they can leverage even more advanced capabilities like doing transaction simulation before deciding to approve or reject a transaction. They can leverage AI capabilities to look at historical data and determine whether they want to approve that transaction. And so depending on the use case, there's a myriad of different options approvers can leverage to increase the level of security that they want to execute over their keys. All of this flexibility is packaged in a very nice API we've provided through Lockkeeper. And that's what I have running locally in the sense that it's just doing a very simple check for a allow list and a transaction value. So I'm going to minimize the approver, and then I'm going to run the wallet that has a bunch of keys that I've generated for Shamir as well as MPC. It shows the simplicity of generating keys, securing them remotely in a Lockkeeper infrastructure where there's enclaves, MPC, and all the bells and whistles. But on the client side, it's a very simple UX. And so each key has a balance of a certain amount of ETH, and each key has a type. So this key is Shamir, and this key is an MPC key. And so I'm going to execute a very simple command to transfer ETH from my Bob key to the Charlie key. And because I have a threshold, a rule of transactions below 1 ETH being auto-approved, I'm going to stick within that threshold for this initial transaction. And so as you can see, the transaction was generated. The approval was given by my local auto approver, and the transaction was broadcast to the blockchain. And so I'm going to show this transaction on Sepolia right now. It takes a couple of seconds. It was successful. 0.5 ETH was transferred. Now I'm going to show the rules to prevent misuse of my assets. So I'm going to execute another transaction, and I'm going to send it to an address that's not in my allow list. So I just grabbed an address that is not on my allow list, but the threshold values is good, and this should fail. And so the auto approver rejects it, and Lockkeeper Core does not sign the transaction. I'm going to do a similar thing and try to transfer a value that's greater than the threshold. That also fails. And so you can see the full breadth of what we can enable very simply for applications. And all it takes is essentially integrating our API and plug and play to achieve a secure wallet functionality in any enterprise type of application, from gaming to AI to digital inheritance to DeFi to restaking. We can support all of these use cases very easily for our customers without them having to be cryptographic experts. All they have to do is integrate the API, leverage our policy framework to express their rules in terms of who the approvers are, and then the approvers can basically have custom logic to make sure that the rules that specific application domain want to enforce is actually being enforced. And that's really the breadth and depth of our demo, showing this on the Ethereum ecosystem, but we can adapt this to any blockchain, any ERC20, NFTs. All of the same logic and orchestration can be brought to any domain within the Web3 space. Thank you.